On a
The size
64-bit
of it.
system, how big is a pointer?
I mean, I've been a C++ guy for like a year and a half now.
Oh, nice. Like
Um,
professionally?
I mean, I have a startup with one of my friends, and
Oh, okay.
we build operating systems.
Oh, savage. Okay.
CJ, can you hear me?
Yeah. What's up?
What's up? Yeah, no, I've been writing down like a couple questions C++. That's good.
Well, maybe you're coming in pretty hot, saying you develop operating systems in university and you have a startup.
It's kind of like, I mean, that's how kind of like how we put it. It's sort of an operating system because like it deals in the command line and whatnot, and it has a like a UI and whatnot.
Well,
So,
well, plenty of programs are command line applications. That doesn't mean they're operating systems.
oh yeah, yeah. No, I understand.
Yeah.
Well, it's kind of like we kind of have the impression that we want to develop it into operating system for rendering and graphics and whatnot.
Okay.
And we use like C++ and OpenGL,
Okay.
and hopefully soon maybe Vulkan and whatnot. So, I mean, we're kind of early and whatnot, but we have
Sure.
many ideas, and I mean, we're spending lots of hours on it and whatnot. I just joined right now. I didn't even know I was gonna freaking get
No,
in this
that's cool,
call, to
bro.
be honest.
That's cool. That's cool. So what's let's start. You wanted some questions, right?
I mean, yeah,
Okay.
yeah,
Okay.
sure, let's do it.
What's the difference between the stack and the heap?
Of course, yeah. So the heap is dynamically allocated, so like you have to use the new keyword and then delete. So you like throw it on dynamically allocated heap, and then the stack is like uh, what is it again? Runtime. Heap is like dynamically allocated, so you use the new keyword and then the delete keyword, and then the stack is like allocated like normally, so you don't have to use you don't have to I mean, like delete it yourself. Like the compiler automatically deletes it for you.
Okay. And how big is the stack usually?
The stack, uh, 4 bytes, eight.
4 bytes?
Uh, I'm not sure. I haven't really dealt with these kind of things. The stack, I mean, is it like, I don't know. I'm gonna say I don't know.
Okay. It's somewhat configurable. The default is usually between 1 megabyte to 8 megabytes.
Okay,
4 on average.
okay,
So yeah, that's usually how big it is. And you'll notice sometimes if you allocate, for example, an array that's too large in C++,
okay,
you might get like a stack, you might get a segmentation fault or some other issue signaling that like the stack has been overrun. It just can't
okay.
fit. This video is sponsored by me. I built this platform called getcracked.io because I noticed that there was a massive skill gap, especially in the world of quantitative trading and higher echelon interviews, between what candidates know and what they need to know. This isn't only focused on data structures and algorithms. I cover a lot of different topics here like concurrency, operating systems, computer architecture, etc. Here we have skill up questions and real world interview questions that focus on practical concepts as opposed to contrived toy puzzles. We also have real coding questions with explanations in case you're stuck in both languages like Python and C++. When do you know what how do I get the address of a variable in C++?
The reference operator.
The ampersand, right. And
Oh
does that
yeah.
return a physical or virtual address?
A give me 1 second. It's a it's no, it's a physical. It's the real copy of it. So
Are you
like,
sure it's a physical address?
well, I was under the impression that when you use the reference symbol that you're using the actual value of like you're trying to use the actual value.
No.
Um,
Well, you
am
are
I?
using the actual value of the address, but the operating system creates a layer of abstraction on the
Yeah.
address space, and it gives the program the illusion that it's running its own private address space, and so it gives it a virtual address, and that virtual address is later translated to a physical
Right.
address. Do you know what hardware is responsible for translating the virtual to physical address?
What hardware is uh
It might be hardware or software. It depends on the architecture. But regardless of if it's hardware managed or software managed, it has a name, and it's usually a three-letter acronym, and it's
T I swear, I heard you talk about this one time. I watch your videos. Uh, is it like TCP? No, right? It's not that.
No, it's not TCP. It does start with a T though.
T- Uh, I haven't took networkings yet. I'm gonna take it next semester.
No, but this is operating systems.
I, oh, it is. Not TCP. I'm not sure.
TLB. Have you heard of TLB?
TLP. Let me read. No, I have not heard about it.
Okay,
No,
so
no.
that's translation look-aside buffer. So that's
Translate.
responsible for the address translation.
Okay, okay.
Now,
Translate. Look aside.
usually,
Okay.
if you were to get that question right, I would ask you about what a page table entry looks like. What a
Well,
page.
I heard about page table, like how there's layers in the operating system and like virtual and physical memory and whatnot. And
Okay, so you've heard of it. I don't like the word heard because I've heard about quantum mechanics. I don't know jack shit about it.
yeah, I heard it.
But you mentioned that you're an OS guy and that you have some degree of familiarity with it by mentioning that you've heard of it. So, what is a page table?
It's like a virtual page in memory where like is it like a virtual page in memory where like when there's too much when the space is filled extra memory goes to the page or whatnot.
No. So, a page table contains page table entries. It's and on a more complex operating systems, or really on modern operating systems, it's an inverted page table. So there's multiple degrees of indirection there. But to explain it in a more beginner-friendly manner, it's an array. It's a linear data structure that
Mm-hmm.
contains page table entries that specify virtual to physical address translations.
Yeah,
And it might contain additional information like dirty bit or other information for uh, managing certain
okay. No, no,
abstractions
I see
around
where you're
that.
going now. Okay, okay. Yeah,
Yeah.
I didn't know that.
Then let's take a step back. All right.
All right.
It is a per process data structure, but let's take a step back.
Per process.
There's two spaces. There's two address spaces in an operating system. What are those two address spaces? And this is not physical virtual. The distinction here has to do with the level of protection.
The level of protection.
Yeah. And the level of accessibility to the developer.
Man, no bells are ringing for some reason. Spaces. Oh man, I'm not sure. Can you give me what is like one of them or what do they start with?
I'll give you one of them.
Okay,
User.
one of them. User space
Yeah, what's the other
and
one?
user space. Not virtual space. Nah, no bells are ringing. I don't know, CJ.
Kernel space?
Kernel space. I would have said no. I don't know that.
Okay. Have you I don't know, I don't want you to tell me what this is. I just want you to tell me if you've heard of it. Have you heard of what an
Kernel
operating
space.
system's kernel is?
I've heard of like what a kernel is, and I'm just not like
Okay, so
these
wait. If you've
questions
heard of what it is, what would you say it is?
like a place of development, like a place where you could operate your systems and develop things and whatnot. I mean, I've
No.
been dealing with like threads, like threading, and um, what else have I been dealing with?
Okay, let's
Multi-threading,
move into a domain
mutexes.
that you feel more comfortable in. You just said threading?
Yeah, like mutexes or threading kind of stuff. I mean,
Okay.
what else have I been learning? Like sleep, wake, sort of things like programming in C a little bit. I
Okay.
mean, stuff like that.
So
Like,
let's talk about that. So you mentioned that, if a thread could be put to sleep,
yeah,
right?
yeah.
So that's a and when would a thread be put to sleep, or why would it be put to sleep?
Uh, you'd put a thread to sleep when you would want another thread to go, like when you would want another system to run or another program to run, because like multi-threading, I feel like is like two programs running at the same time. So you're like trying, so you like that's like race condition. So you'd want
Well, we're
uh,
touching on a bunch of different topics here. A
yes, 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 yes.
multi-threading isn't two programs running at the same time. Multi-threading occurs in a single process or a single program, right?
Okay.
Now, what? Let's take a step back even more. So, what is the main concern of multi-threading? The main downside, the main problem that one needs to be careful about when it comes to using multiple threads within a single process.
Race conditions.
Okay, and what is that?
When two programs or like programs run at the same time, two functions run at the same time.
Well, we're
I'm
talking
jumping
about,
around.
yeah,
I'm
you're jumping
jumping
around.
very
You're jumping
around.
around.
I know, I know, I know.
We're talking about
Uh,
threads, not programs or.
Functions, yes. It, I was under the impression that race conditions is two x running at the same time,
Two
and
x
x
running?
is
And what
x
is
as
x?
in like two functions or two classes or two systems,
Well, two,
two
two, two
threads.
functions can be called at the exact same time, and they operate on different data. There's no issue
Yes,
with that, right?
two of the same.
No, if two functions are called at the exact same time by two separate threads, as long as they're operating on separate data, there's no issue. Even if they're operating on the same data, there's no issue as long as that data is either, and you fill in the blank. Two threads can operate on the same data as long as that data is blank only. What's blank?
Read only.
Yeah,
Read only.
right.
That wasn't confident though.
Yeah,
That was not confident at all. Okay,
right.
but I know of read, write, and whatnot.
Right. So we just talked about the main problem is shared data access. So how would you protect against shared data access in a multi-threaded world?
You use a mutex.
Okay, and what might a mutex do? So if one thread acquires a mutex and another thread tries to acquire it as well, what might happen on the second thread?
It would. You wait. You said if you have one mutex or two mutexes?
One mutex, two threads.
One mutex, two threads. One thread would wait until the other thread is unlocked or like uh, complete, and then it would like send a signal to the other thread saying like it's ready, and then the other thread will uh, run or
Okay, so you brought up a couple of different topics, but in general, you're right that one thread will be notified in some way or another
yeah.
that it's now fair game to continue and access that variable to write
Yep.
to it, okay, or to
Yep.
read to it, depending if there's um, more than one writer,
Yeah,
or if
that's
there's a
what I was.
writer involved. Okay,
Absolutely.
now there is more than one way to implement a mutex, right? You mentioned one way is
Yeah.
to notify the thread to wake up. Say,
Yeah.
hey,
Wait.
buddy, it's time for you to go and do whatever you want to this variable.
Yeah.
There are other approaches. What might another evident approach be here?
Unlock and lock.
Those are method calls,
Oh,
right? Unlock and lock exists in both cases of the condition variable and the case that I'm describing right now.
so one
So
thread might
one is what we call
Mhm.
like a sleep lock. So it's put to
a sleep
sleep.
lock.
But there
Yes.
is another form of locking to prevent that thread from gaining access to the critical section.
Sleep lock and oh my god, I know. Uh, jeez. Sleep lock. Oh my god. Gee, I should know this. Sleep lock and well, okay, so you would okay, so you'd call one thread would be sleeping and then you'd wake one up. Sleep lock.
So in the sleep lock, the thread that needs to wait for the critical section is waiting by sleeping.
Yeah,
But
but you're using
there's
a
another
condition. What?
yeah, and there's
What
another
was
means by which There's another means by which that thread can be prevented from
never
accessing
seen-
the critical section. There's a sleep lock and there's a
Sleep, block, sleep. Oh my God, CJ. I don't know, man. Stop it. Fuck, you're killing me. Okay, SPR. What are you saying? Spit lock? God, dude. Fuck, I don't know, man. Spin lock, spin lock, spin lock. Spin lock, spin
Yeah.
lock. I've never used a spin lock, dude. I've never.
I'm
But
pretty
okay,
sure
I
you
got
have, but you've used it without realizing it. But what might you think a spin lock does? What do you think a spin lock does?
Uh, maybe it will signal back at it. I'm not. Spin lock. Like send a signal and send one back. I'm not sure. I'm not sure.
Well, there's no signaling. It just spins. It just busy waits. It does mindless work.
Busy with. Okay. Yep.
So
right.
you just learned about a busy lock or a spin lock. You learned about a sleep lock.
Yes.
What might be
Yep.
one disadvantage of a spin lock?
That it wait. No. Okay, so a sleep lock will sleep. Okay, wait. So a spin lock is basically busy waiting, and it waits till the other thread is done, but it still does work.
Yeah, it
Is
still
that what
does
you're
work. It
saying?
just like imagine a while loop. It just goes while true, while.
Right, right. So, what can some disadvantages? Well, I could think. Well, a sleep lock has one thread running at a time, so
All locks have one thread running at a time.
well, I
Unless it's
thought
like
you
a
just
shared
said-
lock where you allow multiple reader access, blah blah blah. But look, to keep it simple for this discussion, you know, both a spin lock and a sleep lock, they only allow one thread to gain access to the critical section, but they have different ways by which they achieve that. So what is one
hold on.
disadvantage of a spin lock?
What is one disadvantage of force? Okay, you're saying it is busy with. Does it interact or does it like mess up the other thread or does it like take the process away, maybe taking like too long or somewhat?
I don't know what that means.
No. Like
Okay, I'll give it to you. I'll give it to you because you're not on the right track.
Okay, yeah, I don't know.
What a spin lock does is it wastes resources. It wastes CPU cycles that
Right,
could be
yeah.
used to do meaningful work, right? What might be a
Right,
better
okay.
idea is to put that thread to sleep and unlock resources or preempt that thread and allow another thread to run in its place somewhere
So
else. in
why
the
would you
program.
use a spin lock then? What are
Okay,
some
so that's the
reasons?
next question that you ask that I'd ask in an interview. I'd say, well, we just talked about a disadvantage. What's an advantage? But because you couldn't get the disadvantage right, I'm not sure you can get the advantage right. I'll give you the opportunity. So, what might you think
Sure.
a advantage of using a spin lock over a sleep lock is?
It does waste resources, but it um, gets more work done, or I don't know.
Okay, putting a thread to sleep is an expensive operation. There are certain state accumulated in the CPU's caches, in the TLB. There are certain information that needs to be saved in registers. So doing all that and then waking the thread up, that takes time. But when a thread is spinning, it's considered hot. So as long as it's hot and it's spinning and it's spinning and it's spinning and it's spinning, then if it's now your turn, you're just ready for the race. Think about it like this. You're running in a 100-meter dash. The spin lock dude, he's at the start line and he's ready to go. But the sleep lock dude, he's in the bathroom and or maybe he's taking a nap in the bathroom on the toilet. So what happens if you talked about threads. What happens if a thread goes out of scope without join being called on it? Or is destroyed without join being called on it? So a non-detached thread in C++ goes out of scope, and you didn't call join on it.
Join is JThread, right? Or am I wrong?
That's a C++ 20 edition, but that's
Yeah,
not what I'm referring to now.
I don't know.
Okay, so the
Sim
terminate's called. The program gets shut down.
terminates. Yeah, I guess. Okay, let me type it. Okay, 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 these are all really good. I need that. Okay. Okay, yeah, no. Okay. You like asking a lot about threading and
Well,
concurrency and
I
stuff
only
like that.
go
It's
where,
important.
yeah, I only go where you lead me, and especially
No, no,
if you want to build
100%.
an OS related product, you need to
No, no,
have
for
like a
sure.
very solid grasp of threading.
Nah, man. You're the man, CJ. I'll be watching your videos and you be a hella like not just like very like I swear I'd be thinking this. You're not just very smart. You're also motivating too, bro. Like you be telling like people lock in and stuff like that. And I think it's pretty
Yeah,
cool.
and
So
yeah, I'll let you know how I feel about this at the end, but I wanna talk a little more. Um,
okay, yeah, for sure, for sure.
um, what's the difference between a vector and an array?
Oh yeah, yeah. Vector is dynamically allocated, so and like you could uh okay, well it's dynamically allocated arrays on the stack, vectors on the heap, and vector also is like dynamic. Like you could add and remove. Fuck, I just know it's. I,
All right,
I can,
let's roll with it. Okay, my next question for you, and this will tell me, this usually tells me all I need to know about a candidate. um, what's is a how big is a vector?
uh, 8 bytes. I'm gonna say 8 bytes.
And okay, if you're gonna say 8 bytes, where do those 8 bytes come from?
Uh, the dynamically allocated memory that you allocated, and like that you have to delete it.
So when you okay, 8 bytes, but I want to know like what data member is responsible for those 8 bytes. So a vector is a class and it has a data member that is 8 bytes large, is what you're telling me. What is that data member?
Capacity, size, and the data.
Okay, bro, where are you reading that from? That's not 8 bytes.
Well, I thought you were asking like the members inside of a like
Right, but
vector.
those don't add up to 8 bytes. So it sounds to me like you're reading something.
You think I'm like reading something?
Well, I don't know if you are because three objects, the capacity, size, and pointer are definitely not. They don't add up to 8 bytes. So
Well,
I'm trying to.
I'm talking of just like what I know data members of a vector is.
Okay,
I'm
so
not too sure about the
that's
sizes. I
fine.
know you could get the size with the size of operator,
That's
very
right.
easily, but
Okay, so
like
if it does indeed have three things, capacity, size,
size
and a
and the
data
data.
member, you're right. It does have those three things. How
Right.
big does that make the vector? 8 bytes?
Like I just said, I know like what it holds, but like the capacity, I said 8 byte. Is it 16 bytes? Is it
Well,
4 bytes?
I'm not sure if like I want to know how you're getting to that number. So you're right. It does contain a capacity field, a size field, and a pointer to the data. How are you
Right.
getting the size from those three things? So like when you say it's 4 bytes or it's 16 bytes,
Yeah.
I'm not sure how you're correlating those three things to that size. So maybe tell me, for example, how big is the size of the pointer?
Uh, 4 bytes.
We're talking about a 64-bit system. So 4 bytes on a 64-bit system?
8 bytes.
Okay, you sound uncertain. I just want to make sure you're not guessing and you're confident in the answer.
Yeah. I don't. These are like the size of
Let me rephrase the question on a to be
No,
clear.
no, I get what you're saying. Like I get the question. It's just I've I've never
On a
the size
64-bit
of
system, how big is a pointer?
I'm gonna say 8 bytes.
Okay, that sounds like a guess to me, but let's keep going. So, okay, how big is a capacity? How big is the capacity field on the vector that we just talked about? So we got the size of the pointer, that's one down.
Yes.
The second one, how big is the capacity?
4 bytes.
And
Because it's
what data
integer.
type? What data type is that capacity?
Integer.
No, it's not.
Oh, I'm sorry. Uh, the capacity is the data type. Capacity. I know. I swear. Size T. Size T. Excuse me.
Right. And how big is size T
Size
on a
T.
64-bit system?
Size T. Excuse me. 16 bytes. Fuck.
60 bytes?
No, I said 16.
Oh,
Wrong. Is it 8 or 16?
yeah, it's 8. Do you know what a
Yeah.
string is?
Yeah.
Okay. A string is always
Yeah.
terminated with something. It always ends with something. What does it end with?
A string ends with ending quote, ending quotation.
Ends with a quote?
You said what does a string end with?
Yeah.
Like it's two, um, I mean, like two quotation marks, and then there's a array of characters, or like
I mean,
like
that's how you type a
characters.
string literal. I'm getting at okay, I'll give you a hint. It contains the word terminator.
Null terminator.
Yeah. And what is that? What is that?
I've heard of it a long time ago. It. My gosh. Null terminator. Like when something terminates, when something's null, like it gets terminated immediately, like when there's no value to a data type or data variable.
Yeah, but
Like
what
it
does that
gets,
look like? What if you were to print out what the null terminator looks like? Just or to describe how it looks like.
I couldn't tell you.
Okay.
Something, let me type it.
Okay.
It's
It's
a thing.
the \0.
Wait, are you reading chat?
Am I reading chat?
Wait, is that? Oh no, I'm ready. I wanted to open chat. See what they're saying.
Well, you're not allowed to open chat though. Okay, well, what is?
Ah.
Okay, fine. I'll let you use chat. What does chat
No,
say?
I'm not gonna open chat. No, I wasn't gonna open chat to cheat. I just wanted to like see what they're saying. I don't cheat, CJ. I'm not gonna cheat. Jeez, you're so worried.
I'm not worried. I know you haven't been cheating until now.
No way. What? No, never.
All right, let's focus on the discussion.
Sure.
If you were to apply to like a role for a job, what sort of roles would you apply for? Because that'll help me figure out what I want to ask you.
I think I applied for. I mean, mostly like game developer probably roles. I mean, I think game developing is pretty cool. I'd probably get into that or just like.
Okay.
Okay, that's all I really have. Thanks, CJ.
All right. Do you
Thank
want
you.
me to give you a rating from 1 to 10?
Yes, yeah. And be like kind of harsh too. Like don't be, because I like motivation. What do you think?
Are you a senior
I'm a first semester senior in college. Yes.
and you're studying computer science?
Yes.
1,
Really?
maybe 2.
Oh shoot. Okay.
Yeah. You're definitely not where like you're pretty cooked, honestly. You're not where you
Really?
need to be. You're not where you need to be, especially for your current level. Like you came in here talking about operating systems and all this stuff, and you weren't familiar with what kernel space was or user space. You weren't familiar with like whether or not the ampersand is a virtual address or a physical address or what a page table is. And then I asked you about threading and locks, and you were totally lost. So
Okay.
when I asked you about vector and how big it is too, you had no you essentially had no idea how big a pointer was. You didn't have any idea. Let me think. Um, yeah, it's just like across the board. Like I didn't feel you were confident in almost any answer you gave me, and 90% of the answers were just incorrect.
I know. Thank you. It's good.
Yeah,
I
but I mean,
took
like you
no,
need to
no,
hustle up and grind up, dude. Because honestly, like if you were to
no,
look for a
for sure.
job at this point in time or an internship, you'd have a very difficult time.
I got you. I got you for
That's just
sure.
the brutal truth,
No,
bro. I can lie to
no,
you
no,
and make you
no,
feel good, but
no,
that's just
no,
the
no,
industry.
no. Yeah, I'm on that. I'm on that. Thank
Yeah.
you.
All right, bro.
Thank you a
Take
lot.
it easy. Yeah.
Yeah. Yeah, you too, man.
See ya.